This is Dr.A. Clementeena, Assistant Professor of the Department of Computer Science with Artificial Intelligence. I am here to take you lecture on topic Python OOPS concept. So now let's start. Before getting into the OOPS concept, let's see what are the topics that we are going to cover for today's lecture. Python OOPS, Python inheritance, Python encapsulation, polymorphism in Python, Python objects and classes, Python methods and constructors. So before getting into the OOPS concept, let me just tell you what is Python, why are we using it. So Python is a versatile programming language and it can be used in any platform, hence it is called like a cross platform. So you can use it as any point of OS, like you can use it in Mac or in Windows or in Linux or in any sort of platform that is available, and it is also a user friendly language. So OOPS concepts covers with certain characteristics, but before getting into those characteristics or the concepts, you need to know the main concept evolving around it, that is the class and the object. And the concepts are like encapsulation, abstraction, polymorphism, inheritance, object and class. First, getting into the class. Class is like a holder. So it's like a blueprint of that particular object created there. So a class is considered to be the blueprint of that entire object that you have created. And here we have two instances given here, like we have for the instance variable and also for the static variable given. So here for the instance variable, each object has its own space for its instance variable created. For the class here, and here it is given for the class is static variable, whereas all the instances share the same memory spaces here. So you could see the example given there for the instance variable created under the class km. So your objects have their own spaces given, but here if you could see for the static variable, all share under the same memory space. And the next is how to create a class. So getting into the concept, we need to just see first how to create a class and how to create an object under it. So class, the syntax given for that is class and the class name given. So the syntax goes like this: class, class name, under that the definition or the attributes that you wanted to create under it. So class bike with the attributes given here are the variables, the name and the gear, with the values, so the default arguments as the null value and the 0 value here. And moving on to the objects. So Python object is the instance of the class or just the copy of that particular class that you wanted to create, right? So how it is actually created? So once you have created the class, you are going to just make a copy of it by creating the syntax like object name equal to the class name. So here in the previous slide that we have seen is we have created a class called bike. So here I am just going to invoke that class by creating an object here called bike1. So I will just go with bike1 equal to bike. Here the bike1 is the object that have been created under the class bike. So the same goes here. So if I am going to pass the value for that particular object created, like previously we have created the objects bike1, but I need to just pass the values for the bike1 called gear and the name, with the values there is 11 and mountain bike, and we have to just print it like print f name. You could just see something called f with the placeholder. It is called as a placeholder, which is nothing but the curly brackets given here, and you can also have it like a empty placeholder, or you can have it as a numbered placeholders, which is nothing but you're giving the indexed value inside it or the named attributes inside it. So here name colon, I am just giving the placeholder with what? Bike1 dot name. So I am just calling that bike1 object with the attribute called name, and also the same goes with the bike1 dot gear. So how the output will be reflected in the console, like name, mountain bike, gear is just 11. And going on to the next example, the same, but I am going to create multiple objects for the same class. So class parrot is being created with the attributes called name and the age, and I am going to create the first object under the class parrot. So parrot1 equal to parrot. Here parrot1 is the first object that has been created under the class parrot. So parrot1 dot name equal to blue and parrot1 dot age equals to 10. So I have just given the attributes, I have just passed the values for those attributes as blue and 10. The same goes with the creating the second object, that is parrot2 equal to parrot, and the same attribute I am going to just pass the different value with some other value like WOO, and the age is given as 15. And how will I print it? By using the same, either as a format function, or I can just go with that F, that is also a format function with the placeholder given there. So I can directly invoke the object with the attributes given. So how will I get the output as parrot1 dot name? So I am just going to call that parrot1, which is the object under the class parrot, with the attribute which is passed is as blue, and the value for the age is also 10 year passed. So the output will be given as blue is 10 years old. The same will be replicated for the second object as who is 15 years old. So this is how it goes for the Python creation of object and class. Yeah. Moving on to the next is how do we create a method? Method is the function. So previous slides we have seen how to create a class, how to create objects, how to pass the attributes, how to give the values for it, everything. But now we are just going to see how to create a method or the function under it. So here I have created something called def calculate underscore area of the self. Self is that you are going to pass the same instance of that particular variable. Okay, so print area of room equals to self dot length into self dot breadth. So I am creating an object of that room class as study room and under the class room. So I am going to assign the value to all the attributes given there. So study room dot length equal to 42.5 and the same for the breadth for that particular object as 30.8. Now if I am going to just invoke the particular function calculate underscore area, I will just get into that particular part or the block or the module, and it is given as self. So what it will do, it will just take that instance of that particular attributes value and it will just give the output. Now the output will be what? 42.5 into 30.8, that is nothing but 1309.0. So area of the room will be printed as that in the console. So moving on to the next is how to create multiple objects of the same Python class. Earlier we have seen one example by using that parrot class. The same we are going to see with another class called employee here. But giving a different ID here, but passing a different value for that ID, which is employee ID here given as 0. I am going to create two different objects with the same class employee. So employee 1 and employee 2 are the two different objects that has been created for the same class employee. Now I am going to pass the value, okay, the same attribute, but the values passing for that particular attribute is different. So how will I get the output as employee ID dot first value I have passed is as 1001. So that will be printed, and the next again I have created another object there. So I will be again passing another value, but for the same ID I will be printed as 1002. Okay, moving on to the next is how to access the class attributes using the object. So how to access? Now we have the attributes available. Now if there is more than thousands or 2000 LOCs are given. Now I wanted to invoke a particular object or the particular attribute from that class. I will just go with something called this dot operator. So directly I can just invoke the attributes under the objects, or you can directly invoke the object under the class given there by using the dot operator. Next is the format method, which we have priorly told you. So format method, I can directly go with the format function which is available. Format function, before that format function I need to go something called the constructor creation. So constructor creation is the init function. For the init function it will hold the parameters called self and the attributes that you are going to pass. So here the attributes that are going to be passed is self.name with the name and self.age is the age value passed here. So how will the output will be printed as like my name is with the curly parenthesis. So empty placeholders are given. So empty placeholders you can directly go with that format parameters where I have passed as self.name and self.age. So the first parameter will be passed on for the first empty placeholder and the second parameter will be passed on to the second placeholders given there. So directly I have given some value called John and 25 for that object. So what the output will be given as my name is John and I am 25 years old. So that will be the output for this particular example. using the format method. And the next is coming to Python constructor. So I need to construct, what is this constructor? Constructor is that you're going to initialize a particular function, and after that you're going to create other sub functions under it. Okay, so that is called the constructor. So I'm going to create self with the parameters that I wanted to pass. So here it is given as def init, of that parameters are self comma name with the empty value that is given, and self dot name equal to name. So this is the general default value that you are going to pass. Moving on to the major concept of this lecture is that the concepts behind the Python OOPS is the inheritance. First thing is, the major thing is the inheritance. So inheritance, what is inheritance? You are going to inherit the values from the parent class or from the base class. So here the example is given like vehicles. Under that, so vehicle here is given as the parent. Okay, so from the vehicle, what all the functions or what all the attributes that have been passed or been created that can be invoked or that can be directly taken by the subclasses being created or the child classes being created by the vehicles. So here the child classes are bikes, cars, buses, trucks. So these child classes can inherit the values from the vehicles obviously. And the same goes for the last one also. It's like pedal bikes can inherit the values from the bike, which is actually reflected from the vehicles given there. And this next example given here. So from the class animal, okay, I'm going to create two different functions called eat of self and sleep of self. So the first class I've created two different functions. So under that eat function, I have something called to print I can eat, and the sleep function something called I can sleep. Now I'm going to derive a class from that by calling a dog. Okay, so dog of animal. So now animal is the parent class, and I'm creating a subclass under the animal class, which is dog, and I'm creating another function for that like bark of self. So how the self value, the instance will be printed as I can bark oof oof, it's given. So now if I wanted to create an object for the class dog1 equals to dog, if I wanted to call that particular member of that base class dog1 dot eat and dog1 dot sleep and dog1 dot bark, what will I do? If either it is despite of being created being a child class or the parent class, whatever they inherits from the parent class, that output will be printed. So I will just get the values like I can eat, I can sleep, that is actually by calling the members of the base class. And the next one is like you're calling the member of the derived class, like I can bark oof oof. So all the three lines will be printed on the console. Moving on to the next topic is Python encapsulation. So what do you mean by encapsulating? Encapsulating is like covering the entire class or covering the entire object there. So I will be so encapsulation is equally given it as like your data hiding, or you're protecting the entire data in a capsule content, right? The same way. So here what will I do? I will just encapsulate the data which is already given in the parent class, and I will be just passing it to the child class given there, but until and unless it has been invoked, it is not shared to any other variables under it. So here the class created is computer, and under that there is an example, and with the def init, so constructor is created with the self value passed as max price equal to 900, and the next is like one more function is created called sell of self, selling price with that format function is given, and format of self dot max price is given, and you are going to set that max price with the value there. Okay, this is the three functions given under the class computer. Now let me just create a object, okay, for the computer class. So C equals to computer, C dot sell, and the next is C dot underscore max price equal to 1000, and C dot sell. Again I am calling the same function, but what happens is there you get a different outputs for it. But first output, if you see, there you get only selling price is as 900. The second output also you get it as 900, but even though you have instantiated as 1000, you get only 900. Here what happens is The format function is actually hiding your data. It's like self.maxPrice. So you are going to hide the data, and I'm not going to print the data which you have given it in the user. So you're just going to just print whatever the data which is priorly given or priorly instantiated. So it will just print it as selling price equals to 900. But that's not happening in the next function, because there I'm going to just set the function. I'm not using any sort of format function to hide it or any sort of other encapsulation methods to cover the value there. I am just going to initialize a value as 1000, and that will be printed as the third output there. And moving on to the next is polymorphism. As the topic itself will tell you that polymorph. So you are going to it's a single word, but you will have a different forms for it. So here for the example, if you see, len function is given, but that len function, how does it take a different forms for each and every type? For string, if you take, it is like length of that particular string. But if you list, if you take, it will take the each data element in that particular list. If you take as a dictionary, it will take the key value pair as one particular element there. So the function is actually a single one, but it takes a different form. So that is the polymorphism here. So the same entity, but it has a different operations in it. So the examples given here is class polygon. Okay, I have given one function called def render of self, print the rendering polygon. The same, but then different class is created, like square of polygon, but the same function render of self with some output there, print of rendering square. And the next I've created like class circle of polygon, but again the same function with a different output here. But if I'm going to call like s1 equal to square, s1 I've created an object from the class square. So s1 dot render. So what it will print? It will just print whatever the object under the class, that is square. So you will just have the value for that function. Okay, all the three classes will have the same function, but you are just going to call only for that object. So under the square class, so you will just get rendering square there. And the same I'm going to call for the next. You could see c1 equal to circle. So under the circle class, I'm creating an object called c1. I'm just going to call this c1 dot render. So what will I do? I will just get the output, the same which is being created for that particular circle class, and that object value will be printed. So it will just print rendering circle. So you could just see in this example that you have different class but the same function, and you will have the different outputs for it. So that's called the polymorphism. And coming to the last topic is the abstraction. So abstraction is the hiding your internal implementation and just highlighting the set of values given for it. So here if you could just see, I will have the abstract class and the concrete class. So for the abstract class, we know that, so if it is vehicle, okay, can be driven but you don't know how to drive, okay, how to drive it. But car, you know that we exactly know how to drive a car, okay, that is concrete. If you know it very precisely, then it is concrete. When you don't know, if you are going to hide it by something, then that is going to be the abstraction there. Okay, coming on to the last, that is the key points to remember, whatever we have seen in the lecture. So the object oriented programming makes the program easy to understand as well as efficient. And by using the OOPS concept, it is really very efficient to take up any particular programming language. And since the class is shareable, the code cannot be reused. And data is very safe by using the data abstraction and also by the data encapsulation. And polymorphism also allows the same interfaces but different objects, so programmers can write the code very efficiently.